Hey everybody, Bob Lalonde here with CNC Molds and Stuff and 5 Minutes on the Water. This is going to be one of a 3-part series on how to make a wacky rig soft plastic bait. Kind of had an idea for this. Here, let me just give you a quick overview of the bait. I've got ViaCAD here open on screen, and we'll just rotate it a little bit. Well, let's select that screen. We'll just rotate it a little bit, and you see I've made a quick and simple 3D model of it. So you kind of got an idea what it is. The objective is that it's strictly for wacky rigging. You hook it right here in the middle, and you can rig it so that the hook hangs down with it from the middle this way or this way, and you should have 2 totally different actions on it depending on how you put the hook through the middle of it. If you're using a weighted wacky hook, you could probably fish this with standard plastisol, or if you're using an unweighted hook, you could probably fish this with heavy salt formula of your choosing. I think that you'll get a good wiggle on it, as both ends are fairly thin, so even if you're running too heavy salt and you're not using a soft sinking plastisol to limit the amount of salt that you need, you should still get a good wiggle out of it. Anyway, I haven't cut this. This is just the basics of it, and I'm not going to use this 3D model to actually cut the mold. Not in this case. I mean, I could do this and I could do this and then do a Boolean subtract, and I have a 3D model of the mold cavity. But I'm going to try and show you how to do this in ViaCAD or in CamBam with just CamBam's 2-dimensional tools. And in a few places I'll mention where you can use the 3-dimensional tools that are in CamBam or otherwise, and it might be better. And I'll try and remember to discuss how the strategy might be different depending on which machine you were going to machine this with. For instance, well, let's go straight to CamBam. I'm going to close this file. Don't need to save it since I'm not going to use it. And we'll open up CamBam. Now that bait is about 5 inches long, so we need to make sure we're working around a piece of stock that's of an appropriate size. I tend to like to draw a rectangle that represents the size stock I'll be using. In this case, I'm going to run 6 by 6. I think it'll be adequate. Some of you guys might think that's not enough, given that you need room for sprues and runners and vents and and screws and pins. But you know, this is a demo mold, and hopefully any of you could adapt what I'm going to do here to whatever type of machine you have if you want to make a soft plastic wacky rig mold. Alright, we're going to start. I want the main body to be about 2.5 inches long, so we're going to go, we'd go 2 1/4, but you have to remember that well, we're going to slot this. So now that you know that we're going to slot this, you can see where we're going with it. We'll just throw a line on here, arbitrary length for now, and we'll engrave. Oh, we'll engrave that line with a. Let's see if I have a 3. Oh, I guess I ought to set this up for whatever machine I'm going to be using. Style library. I'm going to run this on the Tormach. It may or may not be the best machine I have for it, but it's the machine we're going to run it on. Now let's see if I have a 3/8 slotting style already defined. We don't need 2 engraved mops for the same thing. Let's see if I have a 3/8 style already designed. I don't remember. Pull up from my style library. Come down here, 3/8 ball slotting. There we go, and I've already got it set to have a target depth of half the diameter, or the radius of the cutter. Alright, Control T to generate toolpath, view, show cut widths, and as you can see, I can't make that line 2.5 inches long if I want a 2.5 inch long body, because it cuts and engrave exactly on the line. So let's see what we have here. Probably the easiest way to do this is to draw a rectangle. I drew a lot of secondary geometry that I don't actually use to generate tools, just to keep track of everything. 0.375 high, 2.5 inches wide, transform, center extents. Now we know that, let's view, show cut width, and let's zoom in on that. I'm using a lot of plugins that aren't part of CamBam per se, but you can download them by going to the CamBam forums and finding where people have added them. Alright, now we know that the radius of a 3/8 cutter is 3/16, and so I've moved the line back 3/16 from my boundary. And if we hit Control T and we view show cut widths, boom, okay, now we've got our 2.5 inch long body. And it's going to be a round body with radiused ends. Now, how do we get the other part? That's easy. We're going to do something very similar. Let's back out on our view. We want this to be about 5 inches long, and I happen to know that, well, I'll show you. Let's draw another line here from somewhere here in the cavity that's going to be created out to, that should be, let's see, that's minus 2.5. That'll do. Alright, and now let's take a front view look at that line. And there it is. Let's start creating some new layers. Call this the cavity. Oh. And let's move those items that are for machining the cavity to that layer, and you see a little arrow right there that shows that that's the active layer. Anything I draw right now will appear on that layer. Now that rectangle's in our way, so let's hide it. I'm not sure what I opened up there, but let's delete that unnecessary geometry. Now let's take a look at this. You can see it's flat. If we engrave that, we're just going to have a flat cylindrical slot. And you can do that. You could maybe use a smaller size cutter and have a flat cylindrical slot that creates a slightly smaller arm at each end of the bait. But our goal here was to have it also tapered. So what I'm going to do is I'm going to put down here to points where it says Edit Collection. And it shows Z0 at both ends. And we're going to change this to, we're going to use a 5/16 cutter. So half of 5/16 is 5/32. Oh, you know, I just realized that's not on the screen that's being recorded. There we go. We're going to come down here. Here's the end that's this end. And here's the height of this end. Now what we're going to do is we're going to use a 5/16 cutter to slot that arm. So we just want to raise that Z up a little bit so it tapers up away. We're going to use a 5/16 cutter. 5 divided by 16. Alright, it's 0.3125 divided by 2. There's our radius. And we want that to angle up to make that thinner arm. So 50 thousandths on each side, 56 thousandths. Let's try 0.1 and see what that looks like. 0.1. Okay. Now you see it angles up. Now what we'll do is we'll select that, do another engrave operation. And I'm pretty sure I don't have a style pre-created for 5/16 slot cutting. So we'll just come down, and I'm not even sure I have a 5/16 tool set up for this machine, but let's take a look. Well, before I take it to the machine, I'll have to set up a 5/16 tool. So for now, we'll just call this tool 99, and we'll call it a ball nose. And we'll 0.3125. And we'll give that a target depth of 0.15625, 0.156625. And don't forget to say minus, because you can have target depths that are not minus, and you can get all confused depending on how you lay out a job. Alright, generate toolpath. Well, that's a little... We could probably... That's probably not enough. And maybe a finish. Final depth increment of 5 thousandths, just sort of a cleanup. Yeah. You can play with the depths. Alright. Well, you think, well, gee, we'll just have an angled cylinder. Actually, we won't. Let's take a look here. Tools, simulate with Camotics. Okay, let's save this file. Save as. Machining projects. My bait molds. And I've actually already started a project for this. I called it Wacky Winger. And we'll just call this Wacky Winger. Okay, tools, simulate with Camotics. I like to create a folder within the folder for a project, just for the G code. And when I'm testing, I like to use the name test so that it doesn't get confused. Alright, let's hide the tool. Hide that. Take a top view, zoom in, and we wind up with a tapered arm or a tapered leg, whatever you want to call it. Now, if you've been around bait making for a while, this may look a little bit familiar to you. This is similar to the way that I think it was Jason at Caney Creek came up with a bait that he called the carrot stick. And I think he sold all of his designs in his company to Do It Molds, and they still produce a bait mold similar to that. So if you're getting close to something you already like, just go over to Do It and buy theirs. Alright, now we're going to continue on with our Wacky Winger here. Let's hide the cut width for now and back out a little bit. We'll just take this angled line, edit, or excuse me, transform, mirror. Now we have two of them, and we can take this same engrave operation and just add that to it. By the way, you press the control key to continue adding. Here, let me show you. If you press off the screen without touching any buttons, you deselect all. And then if I press that one and hit enter, it would just add that one. Or if I press that one and hold the control key and press that one and then hit enter, it adds them both. Now, this is where you run into an efficiency thing. See where it says level first? Well, if we leave it set at level first, it'll cut one depth at this one, and then the same depth at this one, and then the next depth, and then go back to this one and cut the next step. And it'd be kind of slow because it'd be moving back and forth constantly. So what would probably be better would be to set this for depth first. Alright, now we have our operations, and we'll come up here to Tools, Simulate with Camotics. And Camotics is a third-party program, and the Simulate with Camotics is a plug-in by one of the users on the CamBam forum that quickly sets up to simulate what the cut would look like using the Camotics plug-in. Now, there are some issues with the Camotics plug-in that some people may not like. but it works pretty well for the sort of quick and dirty simulation. Here, let's just take a top view and zoom in, and you can see we've got the wacky winger. Now I kind of think that the center part is a little too long and the ends are a little too short, just my feel. You might like it just the way it is, but it's no big deal to come in here and select this line, and instead of two, it looks like 2 1/8 inches long, 1.065 to minus 1.0625 to minus 1.0625. So let's make it minus 0.875 to 0.8875. Now it's too short to meet up with our arms, but we can edit them the same way. And then here we can change that to minus 0.75 and 0.75, and just so long as they overlap a little bit. And actually they don't quite have to overlap even, because one is smaller than the other. If they met at the ends, it'd probably be okay. I kind of like to overlap just to make sure I don't have any ridges left behind. Alright, let's simulate in Camotics again. And let's turn off that, and that, and that, and turn off the toolpaths, and look at it from the top. And that's a nice proportion for my taste. I like the way that looks. So we're going to go with that from this point. Alright, let's turn the overall layout back on. And let's move this to about here. We're going to want a little bit of sprue on top of the first cavity, because if we don't, we'll wind up with dimples in our baits. We want to have plenty of plastic for it to draw on. Now, there are a couple different ways we could go from here. We could just transform, array copy. I don't know, looks like we could probably do about 8 copies. Number of copies, 8. And then 0, that's the x dimension. And then minus 0.5, that would be the y direction, comma 0. It looks like I have 2 commas there. As long as it's more than 3/8, alright? And we could run 8 copies, and then we could sit there and set these 2 operations to work on all of the geometry. We could sit there and take this one, and we could go down here, and we could select all of these, hit enter, and remember what I said about the level first versus depth first. If we have it set for level first, this one's set for depth first, so we're good. So it'll slot this one all the way to depth, then this one all the way to depth, and so on. Then we could do the same thing with this one. Alright, Tools, Simulate with Camotics. Alright, let's turn all of this extra stuff off. It gives us, and we have a rough simulation of an, actually, is that 9, 1, 2, 3, 4, 5, 6, 7, 8, 9 cavity mold. Now, there's a reason that I might not want them that far apart, and this has to do with the properties of the plastic and the aluminum. Aluminum wicks heat away from plastic very quickly. So I might want these closer together to hold heat and have a very thin amount of aluminum in between the cavities. So I might, instead of 0.5, I might go 0.39 or 0.4, have them closer together. I think I'm going to go with 0.4. And yes, I could fit another cavity or two in there, but there's the reasons why I don't want to. Things like alignment pins and venting and clamping screws and so on are a factor. So let's transform, array copy. 8 copies is still good, and we'll go to 0.4 instead of 0.5. That'll put them a lot closer together. Okay, it may seem like it's awful close, but it's really not. If it's separated, it's separated. If that causes a breakthrough for you, you have a really, really sloppy machine. Now, let's see here. I'm going to take these and move them down. I'm going to take, you know what? I think we can go with one more. We could go with 10 cavities. So rather than back up and do it all over again, what I'll do is I'll just copy this one, transform, array copy, and go 1 instead of 8, and keep the same parameter, and boom, okay, now we have a 10 cavity mold. And now this is where it gets to keeping track of stuff. Part 1, let's give that a name, cavities. I like to group my operations kind of by what they do. And I like to rename my operations so that it's useful. Because CamBam embeds some of this information in the code, and it's useful when you're at the machine. 3/8, ball, machine. Actually, let's go slot, main, body. Just for bookkeeping to help keep track of everything. And then we'll rename this one to 5/16 ball, slot, wings. Let's go back and fix this. Now CamBam only selects those items that you encircle when you use that drag box like that. So it's handy for selecting a whole bunch of geometry for an operation, or to move it, or any of a number of other things. It's not a left swipe versus right swipe kind of thing either. It's only what's encircled. Now ViaCAD, which we were using earlier, does have a left swipe and right swipe operation. If you left swipe, it only selects what you encircle, and if you right swipe, it selects anything that you touch. But that's not the case in CamBam. All right, so we basically have something that'll machine the cavities, and because I don't have an operation a style pre-built for a 5/16 ball mill, I need to figure out all the properties for that. And I use a program called HSM Adviser to calculate speeds and feeds, and I kind of use it as a starting point. We're going to come up here and we're going to select the Tormach. I have other machines besides several other machines with different profiles. That's why there are several up there. We're already set for 6061 T6 aluminum. We're going to use solid ball mill made out of carbide, 5/16, and it'll be a 3-flute. Because I like 3-flute mills because they're a combination of good feed rate and good stiffness and good chip clearance. Because when you're cutting cavities, one of the big important things is to get the chips out of the cavity. And when we get to the part 2 video, or maybe the part B of part 1 video, where we're actually machining it, you'll see that I use flood coolant because getting the chips out of the cavities is very important. All right, we've got a feed rate of 58.6. Oh, we don't have our We need to set this as 100% engagement. Recommends 0.06 depth of cut. I tend to like to go a little lighter than that to keep the power requirements down. So I'll probably program it as 0.05 or 0.025 or something like that. And then the one of the things that this kind of doesn't make me comfortable with is it tends to, see, it says width of cut 2779 at that depth of cut. But when you're making those final passes at full depth, I really feel like it doesn't account for that. So I tend to like to have a lighter finish cut or two at full depth. You can kind of hear it chirp a little bit or chatter a little bit in the ends of the slot if you don't do that. So anyway, we've got a feed rate of 55 inches per minute and a plunge feed of 13 inches per minute. So let's go back to our cam file and set this at 55 and this at, well, we'll leave it 10. That's nice and conservative. And then we'll come down here, up here I've got it at 0.025 and 0.005 final depth of cut. We've got the speed set at 5120 RPM, which was the default, or which was what the software recommended, the speed feed software. So that's probably okay. I could even, now I'm going to show you a little trick that you don't need to know right now, but it will come in handy if you start using the styles. I can copy this operation. I can go up into the system folder and come down to my style library for Tormach and new cam style variant 5/16 ball slot. Alright, and then I can hit paste format, and now all of the properties that I had in my operation are copied to this, and now every time I run this, I need to slot with a 5/16 ball mill, I can just pull up this style and it'll populate the operation instead of having to start from scratch. And after I get a tool set up on the machine as a 5/16 ball mill, then I'll want to change the tool number to be the same as whatever the tool number is on the machine, and change it and add it to my tool library. And then change it here in this style, in my style library. Save to XML. Now that style is saved, and anytime I open the program and pull up that style library, it'll be available. That's how you cut the cavities, but that's not where you start. On this particular thing, I would probably start with this. And let's go new part. Setup plate. Let's move that to be the beginning because we would do this first. Now we're going to surface this, and I use a pocket operation that I've preset up for surfacing, and I have a style for it that uses a fly cutter that's already set up for on the machine, so I can just pull up the style and it's done. Generate toolpaths. As you can see, it uses the fly cutter and does its thing and surfaces the plate. If you were using a high-speed machine like one of the SIL Speedmasters or a medium-speed, low-power machine, you might set up a totally different operation using a small end mill to surface the plate and achieve roughly the same result. The fly cutter does a fairly good job on this machine. If I was using, I don't know, a Haas super mini mill with a high-speed spindle, I might use a face mill and feed it a lot faster. But those are all options that you need to decide and figure out for your machine. All right. And if we hit View, Show Cut Widths, you can see that the fly cutter starts cutting and overcuts the entire piece of stock. I want that piece of stock flat when I start. Let me show you. Well, let's View, Show Cut Width. let's rename this Superfly Surface Plate. Now if we go down here, it says stock surface 0, target depth minus 0.01. I actually like to start with a stock surface, set this at stock surface 0.01 and target depth of 0. And then up here in the name, surface plus 0.01. The reason is this machine, or the machine I'm cutting this on, has a tool library, and I'd like to be able to just run the entire job without stopping the program and resetting the tools and resetting the tool height and then restarting the program. By setting that as 0.01 and finishing it to a height of 0, and then when I zero to the top of the stock, I tell it it's 0.01 instead of 0. I guess I shouldn't say 0 to the top of the stock, huh? I 0.01 to the top of the stock. Then everything after that is reference to the stock surface being 0. So I don't have to make any other adjustments in height as I'm coding, as I'm setting up the job. All right. Now, if we wanted to simulate this more accurately, when we go to simulation, because Camotics just automatically takes the toolpaths and assume the stock is bigger than that. So if we wanted to make it simulate more accurately, we might come down here, stock size 6, 6, 0.5, and stock offset -3, -3. Stock surface is 0. And now if we angle this up and take a look, you see you've got an outline of a piece of stock that's the same size as you might use to cut this mold. And now we can go to simulate with Camotics tools. You know what? Before we do, if we wanted to be really accurate, we should set the stock surface as 0.01. All right. Tools. Simulate with Camotics. Test NC already exists. Yep. And we get a fairly accurate representation of what we're going to get out of it when we machine it, or when we machine what's on there so far. Let me take a look and see here. Is this video getting a little bit too long? Well, let me do one or two more things. Alright, new layer, screws. Now we want clamping screws on a mold like this. I tend to go towards more is better. It's better to have clamping points and not use them than to need some clamping points and not have them. Let's see, where are we at there? -175. All right. That should be plenty of clamping screws. Now, I happen to have drill operations pre-set up. I found I get the most accurate drill holes if I spot drill with a heavy, stout spotting drill, and then I come back and drill. So we're going to do two operations. This one will be 1/2 inch spot drill, and this one will be number 21 drill. Number 21 drill is the drill size for a 1032 tap, at least in aluminum, for, I think that's a 75% thread form. In steel, you might use a larger tap or a larger drill if you wanted to and go to a 50% thread form, but that's a matter of choice and necessary strength. I think the 75% thread form does a good job in aluminum, and it's not too difficult to tap. And I'll actually tap this on the machine. Anyway, come up here, style, 1/2 inch spot drill. And we'll come up here and pick the style, number 21 drill. And we can see that. Let's hit View, Show Cut Widths. Let's turn off the surface operation and turn off the spot drill, because it is and make sure that those aren't going to be a conflict, and they're not. All right. It looks like they're going to hit, but it's not, because it's not going to drill that deep. What I've found is, excuse me, is I just need enough spot drill to go in enough to start the drill straight. So here we'll go, those are, and it's a 90-degree spot drill, so half the diameter is the target depth. So we've got now 21 drill is 0.159 if I remember correctly. Yep. And I'd like the spot to be a little bit larger, so we'll go in here and we'll set this as half of 0.16 would be 0.08. We'll just go 0.1. Now, a lot of these drilling operations don't show properly on Camotics, so you really want to double check your work. Make sure it does what you think it's going to do. Oh, minus 0.1. Let's get it right here. Oh, wrong one. This one needs to be minus 0.1. That's our starting spot drill, and that'll produce a hole that's 0.2 inches in diameter, approximately. And because it's a stout heavy drill, it'll be fairly accurate. This one needs to be minus 0.75. Now you say, wait a minute, the stock was only ½ inch thick. Yeah, but there's an angle on the tip of that drill, and you want to make sure it goes all the way through and knocks out any skin left over. As long as I don't have anything under the plate that's going to be damaged by it, like the table or a parallel or something, I just go ahead and drill well through it so that I don't have to worry about it. Now let's now you say, how do we check this? Well, first off, Control-T to generate all our toolpaths, and then let's look at it face edge on to see where we're at. As you can see, that's the depth of our spot drill, and that's the depth of our tap drill, so we're good. You always want to take a look at everything, because after you've destroyed your vise or your table or just the mold itself, just the workpiece, it's too late. You wind up having to start over. Alright, now there is another thing we need, and that's alignment pins. And you might think, oh, we'll just put those right here in the center. Well, you could on some molds, but not on this one, because it's going to have the sprue and runner right here in the center. So let's create a new layer. And you don't really need to have a new layer if you can keep track. You could have one layer that's screws and pins. Alright, and we'll just put a couple of alignment pins in here. And I like to make sure everything is kind of the same, that it looks like it's well thought out. So we're at minus 0.75 and 2.1875, and this will be, and you could put in more alignment pins if you want to, but I don't think it's really necessary. 2 is adequate. I mean, we're talking about soft plastic worms here. We're not talking about high precision parts. And you need a little bit of slop in these, but we'll get to that one on the machining video. Now we have 2 alignment pins. And I use 1/4 inch dowel pins for alignment pins in molds. So I'll drill these twice. Let's move this up here, because that one's going to be a ½ inch spot drill. No sense changing tools twice. And we're going 1/4 inch, so we want to target depth a little bit more than 0.125, or so maybe 0.14. Let's hit minus. Alright. And then here we're going to use the operation for a D drill, and we're going to set the target depth at minus 0.75. Again, you can use a different parameter if you want. Let's pick the spot drill style, spot drill. Alright, Control T. Alright, now what's going to happen is it'll surface it, it'll spot drill for the screws to 0.1, it'll spot drill for the alignment pins to 0.14, it'll drill the tap size hole for the screw, clamping screws, and then it'll drill the press fits hole for the alignment pins. And we'll come down here. Well, we might as well name this while we're at it, just so we can keep track. D-drill pins. Now we can come down here and we'll take a look, and you'll see that a D-drill is, oh, here we go. D-drill is 0.246 inches in diameter, or about 4 thousandths smaller than a 1/4 inch pin. And that's fine in 6061 in aluminum. If you were press fitting these pins into a steel block, you might want to drill that to 0.246 and then ream it to 0.249. I don't think you'd be able to press a stainless steel pin into a steel hole that was 0.246, but it works fine on the aluminum. And then there's one more thing I do to help get the pins started straight when I press them in, and that is one more drill operation. But this one's a little different. 1/4 SE, that SE is square end mill, pin start. And basically I drill it to a depth of 0.125 or deeper with a 1/4 inch square end mill. And a 1/4 inch end mill on anything but the absolute best machines with the best quality end mills is going to wind up drilling a hole that's a few 10 thousandths at least larger than 1/4 inch. So the pin will drop into whatever depth that is. Let's make that 0.15. And what happens, that way the pin will start straight. I can drop the pins in the hole, walk the mold over to the arbor press, and press them straight in without using a pin guide or anything. And I wind up with nice straight setup pins. 1/4 SE pin start. Now that will show up fine on Camotics, the start spin, but the pin start. But these spot drills will show up as 1/2 inch holes. You know, what do you expect for free software? All right. So now we've got most all of the prep work done on the mold. It's just missing vents and sprue and runner, and we'd be done. Now on this mold, you might be able to get away with just venting off the ends. Vent off that end, vent off that end. You might be able to get away with running just a single vent at each end of the cavity. On others, you might want to vent the important points that might trap air bubbles, like right here. There's a little offset that might trap an air bubble at the top of the mold, and so on. I'm not going to bother on this one. If I had to vent that point, then I might not have enough room here, or I might have a vent that touches on both sides and further back and get a little bit of flashing. You know, and if you're making the baits for your own use, that's probably not an issue. If you're making them to sell and you have to clean up flashing, well, that's time is money. And if you're making them for your own use, you know, you can just clean them up as you use them. But I'm not going to vent that for right now. So let's lay out the vents. And let's do a new part. It's not really a new part like a different mold. It's just a way of keeping... Finish up. It's just a way of keeping track of your operations. Alright, let's turn the cut widths off for right now. We'll turn them back on later. Finish up. Alright. Now, see these two things here? These are part of another plugin. They allow you to snap to grid points or snap to objects. Well, in this case, we don't want to snap to this object because it's dangling up in the air. We just want to snap to grid points. And let's create a new layer up here for vents. And we'll draw ourselves a couple vents from here to here Actually, you know what? Let's just draw it right off the end of the plate. I could actually stop it right here because we're going to use another engrave operation, and it would actually extend off the end of the plate a little bit. But I'm a little OCD. I like to see that my control goes off the edge of the plate, or if the plate's not uniform or wasn't cut right or whatever. All right. Then transform, array copy. And we want to change that to 9. You might say 8, but no, remember we added another one, so we'll make that 9. And then we can just take these, because we know the spacing is good, and move them down. I'm holding down the Shift key with those selected and pressing the down arrow to move them. All right. Then I just take those, transform, mirror, vent. Now I'm going to show you, oh, I forgot to change the name of that. I thought I did, vents. Now I'm going to show you another way, another reason why it's useful to group things on different layers. Select all on layer, engrave, then we'll come down here and hit 1/8 square end mill shallow vents. I already have a style set up for that. Change this 1/8 SE vents. The name of the operations gets embedded in comment files in the output code, so it's really handy when you're working, when you go to do a tool change, depending on the machine you're using, that you can just look up at the screen and see what the last comment was, or very recent comments, and you go, oh, okay, it wants me to put in an 1/8" square end mill, and you've put that there. On the machine we're going to run this on, it actually pops up a dialog controlled by the machine that says insert tool whatever. All right. Now we're going to keep the superfly, or the surfacing operation turned off for right now. Now we're going to go View, Show Cut Widths, Control T to generate, and now we have a vent off both ends of every cavity. We're almost done. We want to do a couple more things. Now see here where it says 5/16 ball slot wings. I think I'm going to use a 5/16 runner that intersects all of these cavities. We're going to inject them right through the middle. All right. Engrave that, and we've already built a style that'll work to engrave exactly what we want. So we just come down here where it says 5/16 ball slot. See, it already is going to engrave to half the diameter or the radius of the cutter. We'll get in this case, the runner is also the gates to the cavities. Don't need to put it there. Now you notice I moved this from after the other item. Well, I'm trying to reduce tool changes. You know, when I have to go out to the machine and change the tool. I don't have an automatic tool changer on this machine that we're going to run this on. I did, but I didn't like the way it operated, so I took it off. But so we'll cut the wings, and then we'll cut the runner. And we don't have to make a tool change in between. I try and group things like that. And there are times when you may want to change a tool and then change back to the tool because you have to machine something before you can machine something else. But in general, you want to try and minimize your tool changes so that your program runs faster. All right, generate toolpath. There's our runner. Now we still need to get the plastic into the mold because we've got a runner going between all those cavities and no place to put the plastic in the mold. Now, there are several different ways we can do this, and I'll probably touch on 2 or 3 of them. I'm going to show you a way to do this with just 2D operations first, because all of these are basically they call them 2.5D, 2.5 dimension operations. You know, everything's in X and Y with a depth component. So we're going to try and do it the same way. we're going to well, there's a couple of different ways actually we could do this even with two-dimensional. One would be to just set a line from off here to here and slot that with a 5-inch end mill. Now 5/8 inch, did I say 5-inch? 5/8 inch ball mill. We could just slot that with a 5/8 inch ball mill. But a 5/8 inch ball mill takes a lot of power and a rigid machine to do a good job. If you're running a VF2 or a Super Mini or something like that, you might be able to slot that out with a 5/8 inch end mill, but that's pretty aggressive. I could do it on my Herco mill, but it screams and jumps, and then I need to take a cleanup pass to make it look good. And my Herco mill's a decent machine, but we're doing this on a Tormach, which is basically a high-end hobby machine. So we're going to take a little different approach that doesn't require as much power, might take a little bit more time. Now your average hand injector has a nominal 5/8 inch nozzle on it, and your average hand injected mold has a nominal 5/8 inch injection sprue. And if they were both 5/8 inch, you might be able to hammer that injector into that injection sprue, but you might have a hard time getting it out. So I tend to make injectors with a 0.62, 5/8 is 0.625. I tend to make injectors with a 0.62 nozzle, and I tend to make molds with a 0.63 injection sprue. So we want to create a rectangle right here that overlaps this. And this is still a 2.5D method of doing it using the 2.5D operations available in CamBam. And we go down here, we see we have that width at 0.5, so we'll make it 0.63. Transform, align. We want to center it in X, do nothing in Y, do nothing in Z. Did I get that backwards? Oh, I have to select the item. Duh. Oh, I guess I should bring that on screen. I keep forgetting. I have two monitors here so that I can work on different things at once or have reference material on screen while I'm working on something. And I keep forgetting you guys can't see the second monitor. Here, transform, align, center, nothing, nothing, apply. Now we've got it centered there. Now we can do a profile. We haven't done a profile operation yet. And I don't have a style set up for this, so we'll have to set one up, but we'll get to that. Let's go to some of the other settings in a profile first. Now that's 0.63 inches wide. So we want a depth of half that, target depth of 0.315. Oh, don't forget to set it as minus 0.315. Excuse me. And then we're going to come down here where it says side profile, and we're going to give it a concave radius with a value of 0.315. And this isn't going to work, but first I'm going to show you how it kind of sort of does work. Let's turn off all this other stuff. And oh, we've got that. That should probably be in the overall layout. So let's set that back as the active layer, set as active layer. Hide all but this. And let's zoom in on that item. And we'll hit Control T. And as you can see, it made a nice radius on the outside. So obviously I forgot something. Look at that. It says inside outside, so we'll make it inside. Control T to generate toolpaths. And we've got a nominal 0.63. slot or injection sprue. Now let's simulate that in Camotics. Tool, simulate with Camotics. Just write over the same test file. Turn off the toolpath, the tool, so on. And you can see it sort of did it, but something's not right. We got a flat bottom there. What's the deal? And we're radiused at that end. Now, radius at that end won't hurt anything. But why have we got a flat bottom? So we got to go back and look and see if we did something wrong. Okay, that's 0.63. Pull up my old Windows calculator here. 0.63 divided by 2. It's 0.315, so we got the depth right. Well, one thing is we didn't set a tool, so we'll set this for a 1/4 inch ball mill. And I found a 1/4 inch ball mill is pretty good for this. Of course, we could use a 3/8 ball mill. And that's within the power handling of the machine. It'll handle a 3/8 ball mill just fine. Okay, tools. Simulate with Camotics. Yes. Well, that looks a little better. And we see it looks mostly good, but if we zoom in there, we see we got a little bit of a lip on that edge, which might be why we're getting that square appearance. Because the other end looks nice and round. Well, as round as you can get, you know. So, let's close that. And see, the issue is we've got a 0.3 radius. So this rectangle needs to extend at least 0.3 past the edge of the plate to have a nice, full way of cutting that. Now again, this is all about doing this with CamBam with 2.5D tools. So we can take this and we can double click on it, and just drag these points up a couple, and then we can hit M for measure, and we can measure from there to there. It's 0.25, not quite enough. M for measure. 0.3125, that's probably enough. And we probably, remember when I talked about snap to? I probably ruined the dimension of my, yep, see, by snapping to the grid. So we need to change that back to 0.63. And we need to realign it, transform, align, center on X, no change in Y or Z. Apply. Okay. Now it's the correct size and now this could be an issue on some machines that you're running it on. You may not have almost a third of an inch of extra room beyond your stock to machine that. Now, any way you do this, except for slotting with a 5/8 end mill, any way you do this, you're going to need some clearance off the edge of your stock. This is a way to do it with 2D. This is not the way I would do this job. The way I would do it would be like this. I'd create a 0.63 circle. .63, and then I would break that circle in half, and edit, break at intersections. I don't think I've showed you that yet. All right, and then I delete everything I don't need. Now I have a half circle, right? Select that circle, edit, actually draw, surface, extrude, 0.25 or 2.5. Okay. Now it doesn't look like we created anything, but we actually did. See, we created a surface that we can machine to. Alright, now we have to move that surface into an orientation that's useful to us. So we'll select the surface, and then down here there's a thing called the transformation matrix. There's a lot of things you can do here. You can rotate something, you can translate it, which means move, and you can scale it. We're going to rotate it about the x-axis. I believe it's minus 90 degrees. Oop. 90, not 890. Apply. Okay. Oh, got it backwards. So we can just cancel. We can just hit Control Z, select that surface again, transform, rotate about the x-axis, 90 degrees, apply, OK. Now you see how that let's turn off the view cut width again, show cut width. You see how that looks dark? That tells you that your surface faces are all facing the other way. That means if you try to machine that, it's just going to machine all of whatever your boundary is to the full depth that you set in your operation without any regard to the faces. So we'll just go up here to Edit, Surface, Invert Faces. Oh, I guess we have to select it first. Edit, Surface, Invert Faces. Now it's green like all of the other geometry. And by the way, you can change the color of stuff, but I tend to leave it the default. You know, if I wanted everything in this to be a different color, I could just go down here to the properties for the layer and change it to a different color. Alright. But if I select it, it's going to be red. And changing the color of items on different layers can be useful if you have a whole bunch of stuff crowding things up. Alright, now we're going to take this surface and we're just going to, I'm using Shift and the arrow key just to move it up into the area where I want to put an injection sprue. And I'm going to delete this profile because I'm not going to do it that way. I mean, I wanted to show you how you could do every part of this mold with standard 2D, 2.5D operations, but I'm going to use a 3D operation for this because it's more efficient for me. And I'm going to drag this down, actually. I'm going to drag this down, and I may change the height. 1, 2, 3, 4. And I'm going to use a 1/4 inch end mill. Let me hit Show All. Alright. I want that sprue to come, in this case, I want that sprue to come down very close to where it goes into the cavities because I want a lot of plastic up there, as much as I can have up there for those cavities to draw on as the plastic is cooling and shrinking. Alright, so now we're going to hit that and we're going to do a 3D profile. I would like if it was just 3D operation. We're going to use a 1/4 inch ball mill because I like it for this. Alright. And then we're going to come down here to the style library. 1/4 ball finishing medium coarse. And you can see that I have it set as a depth increment of 0 and a target depth of almost 1/2 inch. And down here I have my step over set at about 5%. Now, step over, since I mentioned it, is a percentage of cutter diameter. It is not a dimension. So if I was using a 1 inch cutter, a 1 inch ball mill, every cut would be 5/100ths of an inch. But at a 1/4 inch end mill, I'm using 1/4 of that. You know, because it's a 1/4 of an inch instead of 1 inch. So step over is a percentage of cutter diameter, as is resolution. And that's how often it checks what depth it should be at when it's doing the calculations. Now, if you need a really rough part that kind of looks like what you want, you might have resolution set at 0.1. You know, but if you want a really fine part, you might set resolution down at 0.01. Which would be 1% of cutter diameter is how often it checks the depth when it's calculating the depth operation on a 3D operation. Now, there's a couple other things. There's at least one other thing here. Down here, where it says shape outline, we have shape outline, bounding box, and selected shapes. We're going to hit selected shapes. If we had shape outline, it would just machine this whole thing from here to here. It would machine the whole thing. And I think it might even machine around it, depending on the type of surface we were working with. Well, obviously that would be an issue. So we're going to hit selected shapes, and then down here where it says boundary shapes, we're going to we select that, and then we select these three little dots. Then we come up here and we select that rectangle. We hit enter, and I'm going to right click on it, generate toolpaths, and it machines within that. Let's make sure there's no, okay, roughing clearance is 0, that's good. Now let's hide that, and let's make sure that that's machining like we think it should be. Yep, it does appear that it's going to be machining a half cylinder for our 0.63 injection sprue. Alright. And let's turn this on. Let's turn this on. Again, we'll leave the we could probably turn that on too, the way it's set up. And let's hit Tools, Simulate with Camotics, and see what we have. Well, looks like everything showed up. Our half-inch spot drill, that's one of the issues that I mentioned before with Camotics, is that it doesn't show a lot of drill operations the way they really look. So let's close that out, go back here and turn off our half-inch spot drills. And pec drill operations don't show up properly either, so those won't hurt our view, but they won't show up properly. But that's one of the reasons why when we were doing them, I said you should turn it this way and make sure everything's doing what you think it should be doing. Alright, Tools, Simulate with Camotics. Alright, let's just get a top view to start with, and let's turn off that and that and that. And if you look, we've got an intersecting runner between all the cavities. We've got a nice 0.63 injection sprue. We've got vents showing off the ends of all the cavities. We got the cavities, and that's basically it. You could basically generate both sides of the molds of this mold with mostly the same operations. To generate the second half, I would probably come in here and just turn the vents off, and I would change this to a number 7 drill, and I would change this to an F drill. A number 7 drill is 0.201 inches, which gives adequate clearance for a screw to go through. And an F drill is 0.256, or 6/1000ths larger than a 1/4 inch pin. So basically all I would do to create the second half of the mold is do everything exactly the same except turn off the vents, because we don't need them in both halves of the mold, and change that to a number 7 drill and change that to an F drill. And that would be it. And I think that's the end of the video. I think that covers everything that I wanted to do to show you how to make a really simple wacky worm mold. I realize there are going to be some people complain about some of it. Let's go ahead and simulate that in Camotics again and discuss the bait itself. And then I'll wrap it up. Alright, let's turn off the quadrant, or the indicator of dimensional direction, and I don't know what that thing's called, and the toolpaths, and take a look at it. You know, obviously you're going to have a little bit of the runner that you can excuse me. You're going to have a runner that when you cut those apart, you'll have a little bit of a nib and of a runner there. If you want to clean that up, you can. If you want to just cut it and fish with it, you can. I don't think the fish are going to care. I think the action of the bait is going to be the determining factor, and I think it's going to have good action, and I think you're going to be able to rig it 2 different ways, so you have two different types of actions with the exact same bait. I think you're going to be able to inject it so that this half is one color and this half is another color. If you orient your two injectors on a dual injector setup with one here and one here, and if you inject it with two injectors with one towards you and one away from you in relation to what you're seeing, the back will be one color and the front will be another color. I don't see any issues with injection at all. In other words, you could make a single color bait, a two-color bait that's one end is one color, one end is the other color, or you can make a two-color bait that one side is one color and the other side is a different color. So I think this is a very simple mold. If you want to make it yourself, that's fine. If you want to buy one from me, I'll make one for you. I don't think this would be very expensive to make, easily under $100. And, you know, have at it. I think it would just be a fun, simple bait that'll catch fish. It'll catch bass anyway. That's about all there is to it. I think that's the wrap-up on this. There will be a part 2 on my other channel, the CNC Molds N Stuff channel, and there will be a part 3 on my other channel, 5 Minutes on the Water. In part 2 on CNC Molds N Stuff, I will machine this mold and I will inject some baits with it and show you how that's done. And on part 3, I will take this out on the water and I will go fishing with it. I probably won't fish it until later in the summer, so it might be, or at least the late spring, so it might be a couple months before that video comes out. But this will be a 3-part video. And here's the bonus for those of you guys who have waited through this long, tedious video. I'm going to make and give away 3 of these molds. I'm going to give away 1 to subscribers of this channel. I'm going to give 1 to subscribers of the CNC Molds N Stuff channel, and I'm going to give 1 to subscribers of the 5 Minutes on the Water channel. But not until each one of those channels has 1,000 subscribers, and that might be a long time because I don't think any of them have more than 200 subscribers now. So promote these channels to your friends, because I'm not giving them away until I have 1,000 subscribers on each channel. And that's it. Oh yeah, and each one will be sent to... Oh, I guess I should tell you how you enter to win. Well, first you have to like this video. You have to subscribe to this channel, or one of the other channels, or all 3 channels, and like the videos that come out on those channels. And I should say or. You don't have to subscribe and like all 3 channels. You have and all 3 videos. But you have to subscribe and like the appropriate video and channel for at least 1 to have a chance of winning one of these molds. And then in the comments, at a first level comment, say, please enter me to win. And that's it. And if you win, or I will notify you in a reply to your comment, and we'll make arrangements to get your shipping address. And I will ship the winners for each mold to anywhere in the world, as long as it's not a restricted nation with the United States. That's it. Thank you for watching.